Now let us see the next part in the construction. So here over these contacts, these are the fixed main contacts and arcing contacts, arc runner. Over this arc runner, this arc splitting plates are provided. So you can see this is the arc splitter. Okay, these are the plates of resin bonded fiberglass special material, and these arc splitting plates are provided over this arc runner. So whatever arc get elongated arc, that elongated arc once enter in the arc splitting plates, the arc get quenched. So that is how high resistance interruption principle is achieved in case of this air circuit breaker, right? Now let us see the I have here the additional DN1 release. So here you can see the open view of DN1 release. So this is the DN1 release which we have additionally in our laboratory. Okay, so this DN1 release, here you can see clearly now there are 12 terminals, so 13 terminals. This first one is S, then it is M2, T2, M1, T1. Same T1, T2, M1, M2 here for Y, and same T1, T2, M1, M2 for R pole, right? Now here you can see the current setting arrangement. So what kind of current setting is there? So it is provided between 0.75, that is 75% to 100%. So whatever primary current of the air circuit breaker we have, that we can very easily set between 75% to 100%. That means suppose I keep it to 75, suppose I keep it to here I keep it to 0.8 suppose. So if I keep it to 0.8, then what it means? It means that I have set 630 into 0.8. That much primary current I have set for the air circuit breaker. If I put to 0.75, I have adjusted the current 0.75 into 630. So likewise, this current I can set on the primary side of the air circuit breaker from 75% to 100% of the CT tap which I am choosing. At presently I have chosen the CT tap of 630 ampere. So that's why with respect to 630 ampere, I am getting the variation from 75% to 100% as far as current setting of the air circuit breaker is concerned, right? Now in order to achieve this overload protection, here you can see the provision of thermal bimetal is made. So here you can see 3 thermal bimetals. This is first, this is second, and this is third. Okay. Now this DN1 release is faulty one. That's why we have replaced this DN1 release by new one in our actual kit, and this faulty one I am using for the demonstration purpose. Now why this DN1 release is faulty? So here you can see 3 thermal bimetals. This is for R pole, this is for Y pole, and this is for B pole. The correct position is for Y pole. Other two R and B, you can see they are permanently get bent on the other side. So that means these two are faulted. These two bimetals are faulty, and that's why this entire DN1 release we have replaced few years back. Okay, and the new one which we have used in the kit, that allows us to perform the overload test and short circuit test successfully. Now see here demonstration how the overload testing, how the air circuit breaker operates during the over circuit breaker. That means this DN1 release how give us the tripping signal. So I will first set this air circuit breaker. So I think this is already in the set position. Now see, when overload is occurring, then this thermal bimetal is going to bend in this way, that is in the forward direction, in this direction. Okay, and see what happens when it bends sufficiently on this direction. See, this lever bar operates so that it has given the tripping signal, and through this mechanical linkages this tripping signal has been given to the main contacts, so that main contact get isolated. So that is how we can get this tripping signal from this DN1 release through this lever bar, through this horizontal aluminum lever, and through that other mechanical linkages which we have in the air circuit breaker. Through that the signal is transferred to the main contacts in order to cause the tripping. Once again, see, I will set this. So this is set. Now during the overload this will bend towards in this direction, this bimetal will bend in this direction. When they sufficiently bend, see what happens, the signal is transferred through this, through this, through this, through this. See, yes, right? So this is how we can get the overload protection signal from the DN1 release. Now let us see the protection from the short circuit release, short circuit test, how the signal is obtained. So again I will set this. So I have set the DN1 release. Now to achieve the short circuit protection, here you can see three magnetic pickup coils. This is first magnetic pickup coil, this is second, and this is third. So actually these three are the armatures of the magnetic pickup coil. So if you see on this side, there you can see three circular shaped, it is actually on the inner side, three circular shaped coils are there below this armature. So in this way it has three magnetic pickup coils, and this is the armature, three armatures of three pickup coils. Okay, now again the signal is transferred through this lever bar, now through this lever bar, through this, and again it is given to this particular linkages. Okay, now let us see how it happens. Now when short circuit occurs, then this armature will get attracted by this magnetic pickup coils. So the armature will go downwards. See, I am now pressing this because I want to demonstrate. Now the armature get attracted. See, now once this get attracted, see, this lever bar is activated, and with this lever bar activated, this circular bar will get rotated and will get the tripping. Now at present one of the spring is not here, so that we are not able to see the actual demonstration, but still you can see with the pressing this armature, this particular signal is how the transferring, and ultimately we are getting this particular signal from this DN1 release in order to isolate the fixed and moving contacts, right? So this is how we can get the protection from the magnetic pickup coil or solenoid coils in case of short circuit protection. And the signal, this is how transferred from DN1 release to the, through different mechanical linkages to the main contacts, right? Now finally we'll see the rating of the air circuit breaker. So here you can see the nameplate of the air circuit breaker. So what is the nameplate says? We can see here it is clearly written that this is air circuit breaker CNCS 630 LNT make, right? And what are the things mentioned here? The first thing is rating. So rating is mentioned 630 ampere. Below that, breaking capacity. So breaking capacity is 36.6 kilo ampere. Next is making capacity 77 kilo ampere. Okay, which proves that making capacity is always greater than the breaking capacity. We have seen it in theory also. The mathematical relation between making and breaking capacity is what? Making capacity is equal to 2.55 times to that of breaking capacity. So that we already seen. Then next rating is short time current rating. So short time current rating for 1 second, it is 25 kilo ampere. So we have seen that this short time current rating is either specified for 1 second or 3 seconds. So in this case it is provided for 1 second. And how much current the breaker is going to sustain successfully? 25 kilo ampere. So even if any fault occurs, and fault current up to 25 kilo ampere can be successfully withstood by this breaker for a duration of 1 second. That is the meaning of STC, right? The next one is voltage, that is rated voltage 415 volt, rated frequency is 50 hertz. Then CT ratio, okay, and it is written on release. So the CT ratio, actually we have already seen the three CTs. And what is the CT ratio? On the primary side, 630-500-400 oblique CT secondary current was 8.75 ampere, right? And then here refer IS. So concern IS is 2516 for this particular ACB. Okay, so this is in short about the nameplate or specifications of the air circuit breaker CNCS 630 LNT make in our laboratory. Now we want to perform 4 different tests on this ACB, as I have told. The first test we will perform will be the under voltage release test. Second will perform will be the shunt release test. Third will perform will be the overload test, and finally fourth test will perform will be the short circuit test. So all these 4 tests one by one we can see now in this next demonstrations one by one, right? So thank you.